If I put you on the surface of Venus right now, you wouldn't just burn or suffocate, you'd be crushed, dissolved, and vaporized in a fraction of a second. And the strangest part? Venus is almost the same size as Earth. Same rock. Same starting ingredients. So what happened to turn Earth's twin into the most hostile place in the solar system? Venus is the second planet from the Sun, and for a long time scientists genuinely thought it might be habitable. It's almost exactly Earth's size, just 5% smaller. It has roughly the same mass, similar gravity, and it's made of the same basic rock and metal. Early 20th century scientists even speculated it might be a swampy jungle planet hidden under those thick, mysterious clouds. They were wrong, spectacularly wrong. And the reason why is one of the best warnings the universe has ever given us. Here's the first problem. Venus's atmosphere is 96% carbon dioxide, and it is insanely dense. The atmospheric pressure on the surface is 92 times what we experience on Earth. That's the same pressure you'd feel nearly a kilometer underwater in Earth's oceans. Except this is at ground level, in open air. If you tried to stand on Venus without protection, that crushing force would destroy your lungs and implode your body instantly. During the space race, Soviet probes sent to land on the surface were built like heavy-duty submarines. Even so, most survived for less than an hour. The absolute record holder, the Venera 13 probe in 1982, managed to transmit data and color images for just 127 minutes before the extreme pressure and heat permanently destroyed its electronics. Then, there's the heat. Venus's surface temperature averages 465 degrees Celsius. That's 869 degrees Fahrenheit. That is hot enough to melt solid lead. It's actually hotter than Mercury, even though Mercury is twice as close to the Sun. Why? A total runaway greenhouse effect. All that dense carbon dioxide traps heat so effectively that Venus simply cannot cool down. Day or night, equator or pole, it remains at the same blistering temperature everywhere all the time. There is no relief, no shade helps, and night brings no cooling. It is uniformly and permanently cooked. And then somehow, it gets worse. Venus's thick clouds aren't made of water vapor, they're made of concentrated sulfuric acid, strong enough to dissolve metal and burn through almost anything. It actually rains on Venus, but the surface is so searingly hot that the acid rain evaporates high in the atmosphere before it ever touches the ground. A phenomenon known as virga. So picture this, a sky raining pure acid that vaporizes mid-fall over a rocky landscape hot enough to melt lead under atmospheric pressure that would crush a submarine. That is Venus, every single second of every single day. So what actually happened? Scientists believe Venus likely once had liquid water oceans billions of years ago. But Venus is slightly closer to the Sun than Earth, and that small distance mattered more than anyone expected. As the young Sun slowly grew brighter and hotter, Venus's oceans began to evaporate. Water vapor itself acts as a potent greenhouse gas, so more evaporation trapped more heat, which in turn evaporated more ocean, creating an irreversible feedback loop. Eventually, intense solar radiation broke the water molecules apart in the upper atmosphere. The light hydrogen escaped into space forever, leaving behind oceans of lost water and a dense blanket of carbon dioxide. This is what astrophysicists call a runaway greenhouse effect, the ultimate real-world example of a planet hitting an environmental point of no return. Here's the question everyone eventually asks. Could Earth end up like Venus? The honest answer is, not from human-caused climate change alone, and not anytime soon. Earth is far enough from the Sun that we aren't at risk of a full runaway greenhouse loop on a human timescale. However, Venus remains deeply relevant. It is living proof that atmospheric physics isn't theoretical. The greenhouse effect is a real planetary force capable of turning a potentially habitable world into an absolute hellscape. Venus sits right next door as the solar system's ultimate cautionary tale. Despite how lethal it is, space agencies are heading back. Major missions targeting the 2030s, including NASA's Da Vinci and Veritas, along with the European Space Agency's Envision, are set to study Venus in high resolution. They will map its hidden surface, sample its atmosphere, and answer the big question: how long did its ancient oceans actually last? And there's an even stranger mystery. High up in Venus's cloud deck, about 50 kilometers off the ground, the temperature and pressure are surprisingly Earth-like. Following controversial detections of gases like phosphine in the atmosphere, some astrobiologists wonder if microbial life could survive floating high above the surface. It's speculative, but it hasn't been ruled out. Venus is a stark reminder that Earth-like in size doesn't mean Earth-safe. Same size, same starting materials, same neighborhood, yet one planet became a haven for life, while the other became a cosmic pressure cooker. The line dividing the two was far thinner than we ever imagined. If you want to see what happens when that same planetary process runs in the opposite direction, a planet that froze and lost its atmosphere completely instead of trapping it, that's Mars, and its story is just as eerie.
If this video helped you actually understand Venus instead of just listing facts at you, hit subscribe. I'm building this channel one planet at a time, and Mars is up next. See you in the next episode.